Okay, so I just want to go over an example of code that uses inheritance, and then a variable name and a method name is going to have the same exact name as the one we inherited from. So we have a class called A, which has an integer I equals 1, and then an integer function, a function that returns an integer called f. And what it does is it returns I. So if the value is 1, it'll return a 1. Now we have another class, B, which extends A. So what does B get? Well, B gets everything that's in A. It gets the variables, it gets the functions, and right now I'm not putting anything in front of here, which we'll talk about in a little while. But right now it's going to get the variables and functions that come from A, plus we can add extra stuff to it. What if the extra stuff that we add is kind of a repeat of the stuff we've already inherited? So what if we do this? We say, well, B not only gets a variable called I, an integer, we're going to have a variable called I anyway, and that's equal to 2. Would you want there to be a compiler error at this point? Now that this one class has two variables with the same exact name? Actually, what happens when you declare a variable twice? I'm not even sure. Anyone know? If in your regular program, if you say int I equals 1 and then say int I equals 4,
it'll tell you it's already been declared.
It'll say no good. It won't just take the most recent one. It'll tell you something's wrong. You declared the same variable twice. Okay. So what would you want to do in this case? In this case, we're inheriting, and then we're saying, okay, now, besides what I've inherited, I also need a variable called I. Would you want to give them a compiler error saying you've declared it twice? And what if they also did this? Suppose they wanted to have a function which happened to have the same name. Would you want to give this a compiler error? And let's say the body of this program, of this function says I equals super plus I, and then return super plus I, just to add a little confusion. Would you want to allow this? So, when we inherit, we take everything from the class we're inheriting from, and then we have the option to add more stuff. What if we start, in this example, I'm just trying to be intentionally difficult. I'm adding a variable with the same exact name that we inherited, and I'm adding another function with the same exact name. What would you do in this case? Would you say, now, compiler, are you declaring the same variable twice? Well, in the case we talked about where you just have two variables, you don't know, there'd be no way to refer to the first one. So the only choices they really have, when you have a program that says int I equals 2, and then later on it says int I, same name, equals 5, anywhere down here, if you allowed this, if you just said, I'll take the most recent one, I'll ignore the first one. Okay, the problem that you'd run into is any references up here, you're using this I, and any references down here, you're using a different I. But you could just say, I'll let the most recent one go through. It turns out the compiler won't allow it. But what they could have done is just said, let the most recent one go through. But then if it started going into a loop, you wouldn't be able to keep track of which one was alive at the moment. So they decided not to let that go through.
But if you extend it, right, then you inherit everything.
You inherit, so yeah, just remember, when you inherit, you get everything that the class you're inheriting from has, and then you can choose to add more stuff. Now what we're doing here is this more stuff we're adding happens to have the same name.
Yeah.
What do you want to allow this? Do you want to not allow this? What would you do? Obviously, if I had a new function called G, there's no problem.
Right.
And if this variable is called J, no problem. They all have different names. But if they start using the same name, do you want to start throwing compiler errors? Or do you want to say, yeah, I can keep track of it all? The other example, you really couldn't keep track of it. You don't. It depends on where you are in the program. But within this class, we can actually keep track. We can make a distinction between this F and this F. This F is the one of our class. And then remember, the keyword super always means the class right above us. So we could say the super's F, which refers to this one. So we can actually keep track of it. It's just a little difficult to keep track of. So would you want to allow this to happen? Or would you want to say to the person, hey, look, pick new names. You know, you're getting too confusing. Right? They could have just said, let this be a compiler error. Can you think of a reason, an argument why it would be a good idea to allow functions with the same name to appear? Now, F is not a meaningful name, but let's say, like, for example, when we were talking about an electric clock, we may have had a method called sound alarm. And for an electric clock, the sound alarm might be a function that says buzz, right? Bzz, right, that's the alarm. If we inherited a radio and made a clock radio out of it, the method sound alarm might now play a radio station. It might have a totally different function. You know, like the method might say something like, is the time of day equal to the time of the alarm? And if so, call the sound alarm function, right? Like as the clock is running, you're checking, you know, if you set your clock for 6 in the morning, as the clock is running, it's 5:30, 5:40, 5:50, you know, it's getting closer and closer to 6 in the morning. When the two times match, we then call the function sound alarm. For a clock that's not a radio, that might be a bell ringing. For a clock that is a radio, the sound alarm function, same exact name, might play a radio station at a certain volume. It might have a totally different meaning. The meaning is the same, but what it does could be totally different after you inherit it. So that's a good reason to want to let functions be able to have the same exact name, but have a different meaning when you inherit it. And then variables, I don't know if there's a real life meaningful reason for allowing it, but since we can access both of them, we could say super to get to the I up here, and we could just refer to this one as I, so we can handle it. So what would the output of this, if somebody was to print this, if somebody was to declare an object of type B, if somebody declared an object of type B and then printed and then called B's F function. So they said system out print line B dot F. What would the output of this program be if they decided to print this? So we're taking a B object. A B object has an I field called set to 2. It also has a super I set to 1. So let's draw this object, just so we know what's going on. We have the data, not the methods. The data for this, there's actually two I's. There's the I, and there's the super I. And it's set like this, right? The super I, its constructor ran. The super I is set to 1. So when it was created, the object was initialized to 1. The I was initialized to 1. And then we have another I, our own personal I, which is set to 2. Now we have a function called F. We also inherited a function called F, but it happens to have the same name. So when somebody calls on object B the function F, which gets called, it's this one that gets called. What does this thing do? It takes our own value of I and sets it to super. We call super F's. Super F's returns a 1. So the 1 gets returned, and then we add to that, and this is like a brain tease exercise. We add our own I, which is 2. So we get the 1 from this function call, and we get the 2 from ourselves. Add those two together, you get 3. You get 3. 3 gets written to I, so this turns to a 3.
Right.
And then we return, what do we return? We return super,
You return 3.
is that right, by the way? Yeah, okay. It's just, we're gonna return 4, right? We're gonna return super F, which goes up here and gets another 1.
Oh, yeah.
This equals 1, and then this adds I, which is our own I, which we incremented to 3. So this would print out a 4. So, you know, it's like a confusing example that kind of gets the point across. Okay. So the fact that we can have method names and variable names match the ones we've inherited. Well, here's another reason why you might allow it. Suppose the class you're inheriting from is some class you bought from some company, and they don't want you to know the names of the variables that they're using, or they don't publish them, and you start making up your own names. And I is a very common variable name for an iterator, right? In the whole world, you know, when you do a for loop, it's always for I equals. So that's a very common name, and there's a lot of common names for variables. And if you use the same one from a package you bought off the shelf, if they use the same variable name and you start getting compiler errors, it's going to be a pain for you. So that's another reason why they would let you use the same variable name when you inherit. And you just, if you ever need to refer to the one in the superclass, if you use the same exact name, and you're aware there's a variable with the same name, you just have to say super dot and the name of the variable. Okay. Can you think of a reason, if you were designing the Java language, where you might have a class that you would say, I don't want anybody to ever inherit from my class? Can you think of an example, or you know, a language reason why you might want to say, I have a class, like let's say for example you use the Java language math class, right? You use the math class. Right, Java math. Have you ever used the math class, like to do square root or something like that? So suppose somebody came along and said, I'm going to create my own class. More math. Extend. Extends math. And then you get everything that came with math, and then you can add more. You start making up your own math. Okay. And can you think of any reason why Java would not want to allow this? So you know, like when you use math, do you give like a path, like what package it's in, what like when you call it, do you say like Java dot, like how did you ever use the math operation? Like if you want to use square root, did you have to say like Java dot language dot math dot square root?
Yes, yeah.
You got to go through the whole path of it.
Yeah.
Now, if somebody did this, how it would how would they call it now? Would they just say more math square root, or would they have to go through the whole? So, in other words, there could be some confusion if something's packaged away into, you know, if there are certain libraries packaged away, and somebody tries to come along and just extend them and make their own class. People might think you could just say more math dot square root. Like even if this was like a wrapper class, meaning a class that does nothing but inherit. Let me call it a math wrapper. So I'm using the word wrapper to mean a class that inherits but adds nothing new. So you might think then it's just the same exact class as before, why even bother having it? But now you can start saying math wrapper dot square root, and that could screw up the way it's packaged together. So there are reasons why you might create a class and you never want the class to be inherited from. You say, this is the final version of it. I don't want somebody inheriting it and then trying to add more to it. So there's a keyword, final, and it's actually, the math class has final. The Java math class is a final class, and it has all the functions in the square root. And then if somebody else ever came along and tried to inherit from it, if you said class more math extends, and then you might have to say the whole path, Java language math. This would actually give you a compiler error. The compiler error would be something like you're not allowed to extend the final class. So you have the option when you're the creator of a class, you can make this class final, meaning nobody could ever inherit from you. They just take it as is, and there's no inheriting from the class. Okay. So now, up till now, whenever I declared a method or a variable, if we said class, let's think of an example we had before. We had a ratio. And then we had, I'm going to leave a little room here, so I'm going to say we had an integer numerator and an integer denominator. And we had let's throw in one constructor. We'll say ratio. The one that takes in no parameters. The one that takes in one that takes in one parameter. This will set the numerator equals, let me do the one with no parameters, keep it real simple. The reason why, if you just recall with constructors, the reason why we wrote a constructor because we weren't happy with the default one is we never want a numerator to be 0. So we decided the default numerator was 0 divided by 1. So numerator equals 0, denominator equals 1. Okay, so if we left this out, we would get a default constructor which would set the numerator to 0 and the denominator to 0. We don't like that. We want denominators to be 1 for mathematical reasons. Okay, and then let's say we had a method that we want the outside world to use, like print value. So we have a method, print value. Okay, and this method would do a this would print out the value of the ratio. I think what we did last class was we had a float equals numerator divided by denominator, and then we said we printed it out. Okay, just as an example, just to throw a few of these concepts around, what I want to start talking about is now protection modifiers. So, right now, if somebody came along and created a ratio, if somebody came along in a main program outside of this class, if they came along and said ratio R equals new ratio and gave no information, a ratio would be created with a numerator of 0 and a denominator of 1. This would be R. This would be R. If somebody then decided, I want to change the numerator, and said R dot num equals 3, they decided they wanted it to be 3 divided by 1. If they did that, all right, they're trying to change this to 3. And then they called print it. R dot print. Print, what do they call it? Print value? Print value. Then a 3 would come out, a 3.0. I think 3.0 would come out. Okay, well, there's something assumed here is that these fields, numerator and denominator, are accessible from the outside world. Code from the outside world can change those. And maybe you want that, maybe you don't. What we might want to do is, this is not a real sophisticated example, but let's say we wanted to have the numerator and denominator not exposed to the outside world. We could let the print function work, but we don't want people to just come in and directly write to the numerator or the denominator. One reason, just for example, might be someone might not know what they're doing and put a 0 on the denominator. Someone might do this. Someone might say denominator equals 0. You know, we don't know how smart they are. They might do that, and we don't want that. So what we might do is say, we want to keep private how we're going to implement the ratio. We might later on decide we don't want it to be an integer over an integer. Maybe we want a float over a float. Oh, does that make sense? You have a numerator that's a float, and a denominator that's a float. I mean, you can, but is it defined in math that the numerators and denominators have to be integers? But we could decide later on, for whatever reason, we don't want to use it. Maybe we want to change them from integers to doubles or integer. What's a big integer?
A long.
What?
Long.
A long, right. We might change this later on to longs, or we might change it to floats or doubles. Who knows? We might change how we want to represent the integer. And we don't want people from the outside world get their code getting screwed up because we've changed ours. So what we can do is we can say some parts of this class are not accessible to the outside world, and some of it is. Now, we could have a routine called set denominator. Instead of letting them write directly to it, we can offer them a routine to do it, and that routine will take in whatever number they're trying to set, and we'll look at it and go, is this a 0? If it's a 0, we'll tell them, you know, we'll throw an exception or something. We'll tell them you can't do that. But if they set it to any number other than 0, we'll accept it. So the way we block the outside world from having access to some parts of our class, remember our class is data and methods. So we can block access to some of the data, all of the data, some of the methods, all of the methods. We can put in a keyword that says private. So we'll make the numerator private and the denominator private. Now, what do you think the constructor is? Is it by nature private or not private? It's kind of, I don't know if it was a good idea that they let you not write, because it's implied to be one thing, so they said you don't have to bother to write it. But what do you think it is?
Oh boy.
It's, yeah, well, would you ever want it? Can you think of, this will come up much later in the class, can you think of an example where you'd want it to be private? The constructor to be private? That will, obviously if it was private, what does that mean? Nobody can ever Nobody can ever do this. Nobody can ever make one of these things.
That's in the same class, or the one in blue at the bottom?
No, like what I wrote in blue is supposedly like the outside world, outside the class. So, okay. We could make well, all right, let's just leave that one out for now. And then this print value, this sounds like something you do want the outside world to do, right? They can print, you give me a ratio, I'll print what its value is. So this one will make public. So that method will be public. And we'll leave the discussion of the ratio. That's an interesting discussion. It almost always seems like it should be public, because the first thing you ever do is you make one of these, and if the outside world can't make these, then why do we even have the class? But, so right now we have the idea of having two different protection words that we can put, keywords that we can put in front of data and methods. Can you think of an example off the top of your head why you would have a method that's private? Meaning a method, which is usually code that sets the variable or tells you what the variable is, somehow interacts, like it interfaces with the data. If you ever think of a reason why within a class you'd want to have a private one. A private one means other methods in the class can call it, but the outside world can't call it. It's probably not too common, but maybe if there was a function like let's say we had a function like what's the radius of a circle and what's the circumference of a circle, we might have they may have a common function that they both want to use, like no, not what's the radius, like what's the circumference and what's the area. Like we could have a circumference function and an area function. So we may have a third function that calculates what the radius is, but only those two functions would ever use it. The outside world will never use it. So we might have a private method that other methods within the class use, but the outside world doesn't. But a general rule of thumb for simple classes, it's almost always true that the data is private and the methods are public. It's not always true, but that's generally the case. Now, since we've talked about inheritance, suppose we had a class that had, public and private either methods or data, and you inherited from them. What would you want to happen? We've got class A, which has a public print value, public print value function, and a private integer I equals 2. And that's the whole class. Now somebody comes along and inherits from this. He extends A. What have we been saying so far? When you inherit, you get everything, right? You get the methods, you get the data. But is that the greatest idea in the world? If you were designing the language, can you think of a reason why the creator of a class might have a problem with you inheriting their private data? Like suppose the way we decided to represent a ratio was like our bit, we're using integers, maybe in the future we'll switch it to longs, but we don't want the outside world to have access to that. Well, what they could do is they could put if this was allowed, if private data was allowed to be was automatically inherited, you could do this. You could create a wrapper class, which is a class that inherits and does nothing else. And you can say we extend A, and now the outside world can say W. Oh, we could put a method in the class. Let me do this. Suppose the creators of this first class never wanted anybody to be able to print out I. This is a bad method, right? Okay, let me do this. We'll make a method called print 2 times I. What does that do? It returns 2 times I. Let me change this name.
But you can change the formula, but I have a specific reason, maybe they don't want you to change that too.
Yeah, what I'm trying to come up with an example of where there would be a method that serves a purpose, but we don't want anyone to ever be able to see this exactly. This isn't the greatest example. I've made it so clear you can figure out what I is just by calling 2 times I. You know. So it's not the greatest example. 2I, and it returns 2 times I. But suppose somebody got nosy and wanted to see I directly. If we inherit everything that's private, they could create a wrapper class, which means they automatically inherit everything, and then they could say print they could add a method that says it's called print I. Print I, which would, because now that it has access to this private field, if we allowed this to happen, we could do this. And we could print it out. And maybe the creator of this class doesn't want this, doesn't want someone to come along, intentionally inherit from it and start printing out the private fields. But then again, maybe they do. Maybe they want to have fields that the outside world doesn't have access to, but inheritors can have access to. It could go either way. So they decided to give both, well, if you were designing language, would you be strict that it has to be one way or the other? Or would you allow it to go both ways and let it be the choice of the designer of the class? There might be, for design reasons, there might be a need to have, obviously the concept of public fields and methods makes sense, right? The outside world has to somehow get to this object. So we need some public stuff. But then the idea of private also makes sense, but what do you do in the inheriting case? Do you allow it to all be inherited? Well, we've kind of made an argument why you shouldn't. You might have an argument for why some fields should never be inherited. Because then people, you can't keep anything private, you can just inherit it, and the inheriting class can expose it to the world. But then there might be a design reason why you want fields to be private, but yet they can be inherited. Maybe you are the designer of this class and this class, and you trust yourself, and you want this stuff to be inherited. So what they decided to do was allow to add a third keyword, not just public and private, but they want to have a third keyword that says, well, it acts like it's private, but you can inherit it. And that word, the word they used to do that, it's not the greatest word in the world. Probably calling it something like private but inheritable might have been a more meaningful word, but they decided to call this third type protected. Protected integer j equals 4.
You can inherit it, but...
So now, if another class came along and inherited this, B extends A, and didn't do anything. It's a wrapper class. It just inherits. It does nothing else. If somebody came along and created an object of type B, made an object of type B, they could say B wait, what did they say? Yeah, no, well, this, okay. If they tried to say bi equals 5, they'll get a compiler error because I is not even part of, it's not even accessible to them. If they said bj from the outside world equals 6, j is protected so you can't access it from the outside world. But if we wanted to write a method within b that operates on j, that method would work, because j would have been inherited.
Operates on J, but you can't change it still, right?
Right, but what we could have done was that we could do this. We could have a method within this class that says, a method called, well, let me make this now a public method. Public void set j. We take in an integer x, and the method says j equals x. Since we inherited j, because j is protected, we can write on its value. We didn't inherit I, so we can't change I. It's like there is no I, we never inherited it. But we can change j. Now, if somebody came along and said, I'll create an object, B of type big B, they can now call the big set j method and set its value to 5. That method will work, and the 5 will set this value. But if they went to write to it directly, if they said change the j field to 5, if they wanted to write directly on the j field, that field is protected. So the class B inherited it, but you can't, it's still protected, it's like it's private. From the point of view of the outside world, it's still private. You can't get to it. So this would have a compiler error. But this one wouldn't. And then if we made a method in here called set I and tried to write on the field I, you can't. We didn't even inherit it. We never got it. It doesn't even know it's there. Now, so these three words, protected, private, and, public, protected, private, these are taken directly from C++. C++ has those three, and those are the only three that C++ has. If in C++, if you leave it out, C++ defaults to private. Not that you need to know that for this class. In Java, and then C++ had this concept, this design concept, that said there might be some classes that want to have, public fields, protected fields, private fields, but there might be other classes that it does a lot of interaction with. And for those other classes, it might want those other classes to have access to the protected and private data fields, even though they're outside the class. So what you can do in C++, and this got a little clumsy, and the creators of Java came up with a way around it. In C++, you could say something like this: friend, class, C, F, and Q. You could build a list of other classes that, and as long as you put them in your list, any object of those classes type, they have access to the private and protected. They can directly access it. And you might need to do this for design review. But you want the rest of the world to be locked out. So they had this concept of friends, and then if you're trying to read the program, you have to look at all the classes and who they're friends with and draw a big map. So Java came up with this idea that they would put classes into packages, and we've used packages before. And any field that's marked protected means it's not accessible to the outside world, but it is accessible to any class within the same package. So you can kind of think of classes in the same package of what C++ thought of classes that are friends with each other. So So protected fields are not accessible to the outside world, but are accessible to any class that's in the same package as your class. And it's accessible to any class that you inherit from. An inheriting class can have access to it too. In Java, if you leave out, if you don't say public, private, or protected, you leave it out, C++ it automatically becomes private. In Java, it becomes this fourth class called default, which is not a keyword. You can't say default integer j. If you just leave it out, it becomes this fourth class called default. And what default is, the official definition of default is accessible to any class in the same package. So you could think of this a few ways. You could think of it as it's public to the package. Public is public to the whole world, even classes outside of your package. So there's a couple of rules of thumb, and since there's a few rules of thumb, everyone gets confused. But you could think of it as two ways. One, you could think of it as public to the package. The other way some people think of it is it's like protected, meaning access to the package, but you can't inherit. The fields don't get inherited. But yeah, so it's basically, default is public to the package you're in. So it's kind of like saying, you can kind of think of it as like private, but anyone in the same package as you becomes friends, like what C++ called friend. So, I don't know. The default thing was to handle the situation, which comes up kind of rare, where you have fields you want to keep private in general, but there's one or two classes you'd like them to have access to. It makes your computing easier, and you package them in the same class. You package them in the same package, and then you don't give it a modifier. Okay.